Good evening, one and all present over here. Myself, Sahil Acharya,
And myself Aryasmman Pradhan.
representing St.Xavier High School, Khandagiri, Bhubaneshwar, Odisha. And today we are going to explain our project Biohydrogen Run Automatic Garbage Collecting Vehicle. Now I will let my friend Aryasmman start with the introduction.
An intellectual named Annie Leonard, a proponent of sustainability, had once said, "There is no such thing as away. When we throw anything away, it must go somewhere," which is also true. Whereas Professor Albert Einstein, the great physicist, had once said, "We cannot solve our problems with the same thinking we used when we created them."
Have you ever wondered how the million tons of waste we generate thrown, destroyed, or recycled? Have you ever wondered the 8 billion population of us living on this earth? How much waste do we generate? How much do we properly use? How much can we recycle? And how much can we convert into green energy? Or have you ever wondered that the products that we get from it are properly utilized or not?
Then, what if this waste can be treated? We know that millions of tons of waste are generated every day, which can be treated, recycled, and utilized in a more compact and a better way without polluting our environment. It can be made into a biofuel like that hydrogen, which has no byproducts on combustion. What if this fuel can be utilized in a more efficient way to create energy, the electrical energy? So, in order to achieve this, we have developed a system of a vehicle and a station that converts bio waste to fuel and fuel to electricity that in turn again is used to collect bio waste automatically without a driver. This system, as we call, is the biohydrogen
Hydrogen
operated
operated automatic
automatic garbage
garbage
collecting
collecting
vehicle.
vehicle.
There are many problems for which we have found this solution. We will be discussing some of the major problems here.
As you know, in the graph given here, the CO2 emission chart by sector. As you can see, the transportation sector makes the most amount of CO2 emission, while the electrical generation sector, the industrial and the residential sector makes the least. And below you can see the various problems that have been concentrated into the following, which are the cause for which our solution is being made. The first problem is lack of power plants that convert waste to green fuel.
And the lack of a properly managed and maintained waste collecting system.
Lack of areas to use green fuel.
Lack of efficient way to convert the green fuel into other forms of energy.
Excessive pollution due to lack of use of fuel whose byproducts are harmless to the environment.
Discussing smells of waste caused by stacking of waste.
Lack of using green energy in a cyclic process, and
Last but not the least, the lack of proper driving and garbage collecting vehicles.
problems in detailed examples. Number 1. India now has only 12 waste to green fuel converting power plants, which is quite low as compared to those in European and American countries.
And also observed by the people, the garbage vans that have been arranged by the government, which is going to two to three colonies, had been working inefficiently by the man. Sometimes they do not even collect waste from some of the houses of the colony. That this waste stay and makes the area unhygienic and smelly.
Due to the less number of power plants, very less amount of green fuel is produced, which isn't even properly used. It's still now only used for cooking, not even as a fuel to run a vehicle.
But these green fuels, like biohydrogen, is not as efficient if used directly in an internal combustion engine, which produces high or tremendous amount of energy. Thus, it needs to be used in a more efficient so that it can be converted into usable form of energy like heat or in our case electricity.
The fuels like gasoline, diesel, CNG, etc., that we use regularly cause intensive pollution by releasing pollutants like CO2, SO2, N2O, suspended particulate matter, etc. Thus, a fuel whose byproducts are harmless needs to be used. This is referred to as a clean fuel.
The waste are stacked if fermented all together and thus causing disgusting smell that also creates an unhygienic surrounding. Next, the ones driving the garbage collecting truck are not too careful and disciplined, thus they commit unforgivable mistakes.
It has been reported that many people have been killed by being hit by this van due to reckless driving of the drivers. Is it possible to save those people's life? Or is it possible to change this whole system so they can be more safe? In this system, biowaste is converted to H2, a green fuel, by dark fermentation, which then is purified off to CO2, and the pure hydrogen is then stored in a tank, which leads to a hydrogen fuel cell. There it reacts with oxygen to give water and electricity. This is then used as energy by the vehicle as it is run by electric motor and microprocessor. The vehicle is an automatic driven and stops when it sees humans or animals or some objects in front of it instantly. It stops by every house automatically and collects the waste from the bins and then goes to the next house. After collecting as much as it could, it returns to the station where the tank or the fuel cell etc. is situated to deposit the waste, and then it recharges from the electricity that is produced by the fuel cell. After it reacts with the oxygen that is released into the fuel cell. The water which is formed by the fuel cell is stored in a separate tank for commercial use. The process included the many different processes, so we will be explaining each of it in graphical presentation. So the processes are
The fermentation of biowaste, the microbes, catalysts, and enzyme utilization in the fermented tank, then the purification of hydrogen, next being the storage of the hydrogen, and a very important one, the working of our hydrogen fuel cell, lastly, the working of the vehicle and its controls.
Now we will be starting with the fermentation of biowaste. As you can see, this is what we refer to as biowaste. This contains almost 50 to 56% of organic matter and the rest metals, glass and plastics etc. So we are gonna convert this waste into something useful that we can use for as green fuel. So as you can see here, this is our fermenter. The car goes to the fermenter and it gives the waste to the garbage inlet pipe. This waste then gets inserted into the fermenter. The fermenter is a large tank and it has inlets for enzyme and catalyst to go into the fermenter, and also inlet for H2O from the water tank to go into the fermenter. From here, it almost takes 24 hours for the waste to be fermented into hydrogen and carbon dioxide. The reaction can be seen here. As you can see, 500 glucose along with 3000 moles of water is converted into 3000 moles of carbon dioxide and 6000 moles of hydrogen, which is a huge produce. And you can also see a flowchart diagram of our fermenter here. As you are able to see, here is the biowaste inlet, here is the water inlet, here is the enzyme and catalyst microbe inlet, here is where the H2 and CO2 mixture goes into the next tank, which is the purification tank.
You will be wondering, is there any way to fasten the process or increase any productivity? Of course, there is. We could do that by adding some few things. Namely, they are the microbes, catalysts, and the enzymes. We will be using microbes such as the Escherichia coli, the Enterobacter, the aerogens, the Cytobacter intermedius, the Enterobacter cloacis, Ruminococcus albus, Clostridium benjanicki, and Clostridium paraputrificum. With such bacteria, the highest yield obtained for low pH and short residence time of the waste in the fermenter. The substrate this time contains biomass, food, organic waste, etc., which consists mostly of glucose.
It
Roughly,
was found that Clostridium butyricium grows a complete sugar depletion after 24 hours, while doing a maximum hydrogen production after 48 hours. So, in order to have high efficiency, We are using Clostridium butyricium and Escherichia coli in this fermentation process.
In order to increase efficiency by catalysts, we will be using some catalysts, namely
Calcium oxide, CaO,
the calcium peroxide.
calcium carbonate.
So we will be mixing these three together and will be using a 22.5 milligram of this mixture in the fermenter during this fermentation process.
We will also be using hydrogenase enzyme for better production if possible. Hydrogen purification. After fermentation, we get a mixture of hydrogen and carbon dioxide which cannot be properly utilized in the fuel cell. Thus, we need to purify it. As you know, carbon dioxide cannot be absorbed directly. So, we found a compound that can react with carbon dioxide to absorb it. Usually purification of gaseous mixtures is done by fractional distillation, but because the mixture contains hydrogen which is highly inflammable, and fractional distillation is a lengthy process requiring large area and consuming a lot of energy, we didn't do fractional distillation. We used a chemical substance known as lithium hydroxide monohydrate with the formula LiOH.H2O. So in our case, 6000 moles of lithium hydroxide monohydrate will react with 3000 moles of carbon dioxide to produce 3000 moles of lithium carbonate and 9000 moles of water. The water is liberated in its gaseous state, which would also hinder the purity of hydrogen. Thus, it is condensed using a cold water condenser, which then goes to be stored in a water tank. Thus, our hydrogen is completely purified and is sent to the hydrogen storage tank. The byproduct of this reaction is lithium carbonate is a very useful medicinal drug. As you would have known, it is used for manic depression disorder. 6000 moles of lithium hydroxide monohydrate into H2O is an aqueous solution plus 3000 moles of carbon dioxide in gaseous state forms 3000 moles of lithium carbonate in solid state plus 9000 moles of water in gaseous state. For our purpose, we will be using a purification tank of capacity 4 kiloliter.
Storage of hydrogen is a very difficult process because we need to save it at the utmost safety as a slight combustion can lead to its explosion and causing a lot of destruction. So let's see how it will be avoided.
At 700 bar, a storage system would have a volume of about 200 liters or 3 to 4 times the volume of gasoline tanks. The key challenge in it is how to store hydrogen in more amount by applying pressure that we could apply without overheating anything. So in order to achieve this, we are using a nozzle which will pressurize the gas a little so that it can be stored in a small area. In order to provide maximum safety possible without any leakage, we are making the storage tank using carbon fiber and stainless steel as we prefer to make it light and as strong as possible. And in this diagram, you can see the shape and the figure of the hydrogen storage tank. You can see it's made of carbon fiber composite and its inner side is made of high density polymer liner. And as we have a large amount of hydrogen produced, so we will be using a hydrogen tank of capacity 8 kiloliter and of dimensions 2 meter into 2 meter into 2 meter. Hydrogen fuel cell. While using hydrogen in fuel cell to produce electricity, everyone has a common question, i.e., why hydrogen is used for production of electricity but not for direct combustion. The following reasons are: number one, hydrogen when used in this process provides very high efficiency of 70%, in which this way hydrogen of mass 5 kg can be used to travel 300 miles without any hindrance, while hydrogen is very inflammable gas which does not produce spontaneous combustion and generates a lot of heat. It's like almost 1 gram of hydrogen can produce 150 kilojoule, which is very high and might affect the whole surrounding. Thus, we do not use it in combustion engine and we use it in fuel cell.
In order to understand a fuel cell, we need to know its component first. This is the anode where the hydrogen gas is sent through from the hydrogen storage tank through an outlet of the hydrogen storage tank, but which is the inlet for the fuel cell. This hydrogen in at the anode is oxidized to form H plus ions, which then reacts with the OH minus ions of the KOH or the concentrated KOH, which is used as the catalyst here. Then a 4 electrons are produced, which in turn help in producing electricity. Next, from the O2 is supplied through inlet, as you can see here from here. Then this O2 travels to the cathode where it gets reduced to form its ion and reacts with water to produce OH minus ions, which then reacts with the K plus produced here due to the reaction of hydrogen with KOH, and this K plus, which when reacted with OH minus again stabilizes the amount of KOH. As a result, the amount of catalyst remains the same. In this process, we get a total output of 0.9 volts. So, since we are doing a reaction for 100 kg waste, which contains 90% of it to be glucose, we have 6000 moles of hydrogen, 3000 moles of oxygen, and which produces 6000 mole of H2O. That means we are doing this reaction 3000 times. As we know, in one reaction we are getting 0.9 volt, so 3000 reactions, see how much we could get. It is around 2.7 kilovolt, which is highly efficient. So inside the fuel cell, this is the anode made of platinum, which the hydrogen is sent. This is the cathode made of nickel, where oxygen is sent, while this is the catalyst, the potassium hydroxide, which forms after reacting 0.9 kilovolt of electricity.
Working and control of the vehicle. The vehicle is a microprocessor run automatic vehicle which runs on electricity that is produced by the fuel cell, and it collects waste from houses in two different cabins, one for biodegradable and another for non-biodegradable, and it collects these and deposits in the station. The waste is then processed as usual and then converted through many different processes into electricity, and this electricity is then passed on to the vehicle, which then stores it in its battery, and then again the same process starts. This robot has auto braking feature. Let me show you how it works. As you can probably see, this is the prototype robot we have made. As not having enough time, we can make this much, but still it works pretty well. As you can see, I can move it forward because now I am controlling it with RC, but we can also control it with line following systems. So as you can see, I can move it as long as I wish along with any path I want. But when someone comes, for example my friend's hand, then see, it doesn't move. Then when a friend removes his hand, then it is able to freely move. As you can see, this technology is what is referred to as sensor technology. This thing uses infrared sensors which shut up the connections. As you can see, the green light is being shut up. Then we can control this by three ways, as I have mentioned: by RC, by line following, by sensory navigation, which is not possible to do right now. But as you know, the robots that clean our houses, for example the automated robots, they use sensory navigation. The microprocessor used here in the robot can be Arduino, Node MCU, or a Raspberry Pi. So in the overall, what we are doing is, this vehicle, after collecting garbage from here, which then deposited here, will move from here and will go towards this inlet for garbage, where it will get fermented in the fermenter, then sent to the purification of hydrogen and carbon dioxide in purification tank. Then the H2O will be removed by condenser and sent to water tank. Then this hydrogen will be sent for storage, and next it will send with the fuel cell, where electricity will be produced and will be used to reach our vehicle and to work. This vehicle works by using electricity from this fuel cell generated, and this has also auto braking systems like sensor. We will be developing it further, so you can see more features like automatic garbage collection and also automatic line navigation.
So at last, you'd like to know its conclusion along with its advantages. The following as its advantages. It causes zero pollution. Could you find any pollution what we have done?
Waste properly used. As you see, all the waste are being fermented in the fermenter.
Next, we have produced high profit after selling the produces like the lithium carbonate, which is used to treat manic depressing disorders.
We have used zero fossil fuels here.
And the extra electricity produced can be used for many purposes.
Least possible manpower needed to operate.
And the automated safe driverless garbage collecting vehicle does no accident.
Only limitation is the money invested, which can be regained with numerous profits after the system produce is sold, which is almost 8 lakhs.
Thank you.
Thank you.